On July 21, 2024, a rover on Mars drilled into a striped rock sitting in an ancient dried riverbed. Nobody announced anything. Nobody held a press conference. The data sat for over a year while scientists quietly scrutinized every detail. Then on September 10, 2025, NASA published the results in the journal Nature. The sample, nicknamed Sapphire Canyon, represents the strongest evidence yet for ancient microbial life on Mars, containing distinctive mineral patterns and organic signatures that, on Earth, are typically associated with biological processes. Not confirmed, not proven, but closer than we have ever been. And Mars is only one of 3 places this is happening simultaneously right now. Drop where you are watching from, and stay, because one of these discoveries involves something produced exclusively by life on Earth, detected 124 light-years away. Start with what scientists actually mean when they say biosignature, because the word gets used loosely and the precision matters enormously here. A biosignature is not proof of life. It is a chemical, mineral, or structural signal that, on Earth, is either produced by living things or strongly associated with their presence. Finding one on another world does not confirm life exists there. It means the case for investigating further just became significantly stronger. That distinction is why September 2025 was significant without being a declaration. NASA's Perseverance rover came upon the rock called Chayava Falls in July 2024 while exploring the Bright Angel Formation, an ancient river valley carved by water that once rushed into Mars' Jezero crater, a quarter-mile wide and billions of years old. What the rover found on that rock was unusual. Perseverance discovered leopard spots, a distinctive, scattered pattern of dark and bright mineral patches across the rock's surface. Scientists think the spots may indicate that, billions of years ago, chemical reactions in this rock could have supported microbial life. When scientists analyzed the data, they found 2 types of iron-rich minerals arranged in that spotted pattern. Both are associated with life on Earth. One forms around decomposing organic matter. The other is produced by certain microbes. The rock also showed signs that water had once flowed over it and contained organic molecules, the building blocks of life. Here is the critical detail that separates this from previous Mars findings. The Chayava Falls rock shows no signs of exposure to the high heat or acidity usually required for these minerals to form without biology. On Earth, the only common explanation for this combination of minerals in this arrangement is biological activity. That does not mean life made it. It means non-biological explanations are harder to construct for this rock than for anything found on Mars before. NASA's acting administrator called this finding the closest we have ever come to discovering life on Mars. The one definitive way to resolve it, returning the Sapphire Canyon sample to Earth, where advanced laboratory tools can distinguish biological from non-biological origins, is still years away. The Mars sample return mission has not yet launched. The sample sits in a sealed tube on the Martian surface. Meanwhile, 124 light-years away, something even harder to explain was being detected in the atmosphere of a completely different world. Subscribe before we go further. What Webb detected on K2-18b is the finding that divided the scientific community more sharply than anything in 2024 and 2025 combined. K2-18b is a planet larger than Earth, orbiting a cool dwarf star in the habitable zone, the region where liquid water could exist on a surface. Its atmosphere is hydrogen-rich, and its surface may be covered by a vast liquid water ocean. The James Webb Space Telescope analyzed the light passing through its atmosphere. Inside that light, a chemical fingerprint of every gas present. And among those gases, Cambridge University astronomer Niku Madhusudhan's team found something that stopped the room. Dimethyl sulfide, DMS, appeared in the atmospheric data. On Earth, DMS is produced almost exclusively by marine phytoplankton. It is the compound that gives the ocean its distinctive smell. It has no confirmed non-biological source in Earth's chemistry. NASA reported at the time, on Earth, this is only produced by life. That sentence spread everywhere. Then came the pushback. A separate research team at UC Riverside concluded that the Webb signal strongly overlaps with methane, and that distinguishing DMS from methane is likely beyond the current instrument's capability. They did not rule out DMS entirely, but they concluded the signal was not conclusive. 2 teams, same data, opposite conclusions. Scientists at MIT have since identified 15 potential biosignature gases to watch for in exoplanet atmospheres, including chlorofluorocarbons and molecular oxygen, noting that there is no single silver bullet biosignature. Spectra can be interpreted in multiple ways, and this generation of telescopes may be identifying the strongest candidates for the next set of instruments to confirm. That is what is actually happening right now. Not discovery, detection of candidates, building a shortlist, developing the tools to investigate those candidates more precisely. Webb has already analyzed the chemistry of over 100 exoplanet atmospheres. NASA has confirmed more than 6,000 exoplanets, with thousands more candidates awaiting confirmation. Upcoming missions, including the Nancy Grace Roman Space Telescope and the Habitable Worlds Observatory, are being designed specifically to find Earth-sized rocky planets and read their atmospheric chemistry with far greater precision than Webb allows. The frustrating truth is that the tools adequate to confirm life on an exoplanet do not yet exist. What exists right now is sufficient to find the most promising suspects and flag them for the instruments being built today. But the search is not only happening in deep space. The most accessible candidate in the entire solar system is already drawing focused attention, and it is not Mars. There is something I held back at the start of this video, a discovery much closer to home that scientists consider more likely to yield confirmed extraterrestrial life within our lifetimes than any exoplanet. It is not on a planet. It is on a moon. Europa, one of Jupiter's icy moons, and Enceladus, one of Saturn's, both show signs of subsurface liquid water oceans and hydrothermal activity, conditions that on Earth consistently support microbial life even in complete darkness, miles below the surface. Enceladus actively vents water ice from its south pole into space through geysers visible from orbit. When the Cassini spacecraft flew through those plumes, it detected water vapor, organic molecules, molecular hydrogen, the same chemical signature produced by hydrothermal vents on Earth's seafloor, where life thrives without any sunlight at all. ESA has begun planning a dedicated mission to Enceladus. NASA's Europa Clipper, already launched, is en route to Jupiter to study Europa's ocean more closely. The building blocks of living organisms, including amino acids, nucleic bases, and sugars, have been found in so many space environments that their presence alone no longer surprises scientists. What would surprise them, what would change everything, is finding those molecules actively organized into metabolic processes, consuming energy, producing byproducts, reproducing. That bar is high, but the environments to look for it are now mapped. ESA's Rosalind Franklin rover will fly to Mars in 2028 and will drill underground, deeper than any previous mission, to look for life signatures in environments shielded from the radiation that sterilizes the surface. The James Webb Space Telescope has given scientists new abilities to use chemical clues to study distant worlds. Researchers say that more detections of biosignature hints are inevitable as humanity identifies more exoplanets and builds more powerful instruments to study them. What changed in 2024 and 2025 was not a single dramatic announcement. It was convergence. Multiple independent lines of investigation, on Mars, in the atmosphere of a distant ocean world, in the plumes of Saturn's moon, in the data from 100 analyzed exoplanet atmospheres, all pointing toward the same uncomfortable possibility. The universe is not sterile. The question is no longer whether the conditions for life exist elsewhere. More than 5,800 confirmed exoplanets exist in our galaxy, with trillions believed to orbit other stars. Models predict billions of potentially habitable worlds in the Milky Way alone. The question now is whether we are fast enough and precise enough to find the signal before it fades into noise. There is one moon in this solar system actively venting ocean water into space right now, and scientists believe whatever lives in that ocean, if anything does, may already be riding those plumes where a spacecraft could sample it without ever landing. Watch that video next. That moon is Enceladus, and the mission to find out is already being planned.